Hey folks, welcome to Stunt Rigging Toolbox Talk about base stations. We started the other time, the last time you watched, and it was shot from above by myself, so it was technically very difficult to understand. So rather than do that again, I'm going to give a strict attention to just to base stations. Two things about base stations. One, they have to be anchored correctly to the floor. And two, you have to maintain your center lines, both in a lateral and a vertical position for all of your various items to work. So a base station may comprise a ratchet, may comprise a gold tail, may comprise a clutch, may have all of these working in a system. Today's station that's here, because it's a piece of truss, I've got a ratchet on it, which will do the pulling functions with an adjustable take-up on it. And I also have a secondary system of a gold tail and a clutch with a turnaround sheave. So this setup, the way it's set up right now, could be used to ratchet someone off of a balcony and drop them 2 stories to the floor. You ratchet them, you tighten the ram up, it's locked off, and then you do all the drop function in the service loop you've put in from your head block. And a service loop is simply, there's 2 pulleys, a bight between the 2 running pulleys, and you attach to that. Now you can either 1-to-1 it, because remember, you're in the bight, that now makes it a 1-to-2 reverse. For every bit you pull twice as much rope. So the weight increases double. If that's too much for your system down here for what you want to do, you can always 1-to-2 it by tying a sheave to your bottom to the ground, running it up through a pulley and back down to this operating line, and thereby reversing it so you end up with a 1-to-1 in combination. These are all the various ways we can configure things, but this is a base station that can accomplish multiple things, and it's typical of a normal small base station. So to do base stations, this is 300 mil truss, plated truss. I use plated truss because I'm tired of eggs and various things that get beat up in pins and everything else. It's not quite as strong, but in the overall world, this is Extreme Structures heavy duty truss. It's more than strong enough for what we normally do. So you have 300 millimeter truss on the ground. We mount this not directly on the ground. We put it on what's called stickers or cribbing, or whatever country you're in, packing. It's a way of bringing the truss off the ground so you can also work on the bottom cords here. So you can get a span set under here. You can get a clamp around this. You can utilize it. Plus, point 2 is it's not hammered into the cement. So you're not scarring up your truss by sucking it into asphalt or cement or dirt. And the third really important part is if it's not level, with these stickers, you can always put wedges under it. If it's not level, it'll torsionally twist the top truss when you ratchet it down and you risk bending your truss. So by putting stickers under it, you can play games with the level, with keeping it in condition and making it nice. So we always put packing, stickers, cribbing, whatever you want to call it, under the truss. In this case, it's 25 by 50, relatively soft pine wood, 400 mil long. It's a little wider than the truss. In Imperial, that'd be 1 by 2. We have boxes of them cut to put under all of our base stations. Yeah, the ratchets here, we'll ignore that for a moment. Pinning the truss down. You always want diagonals, and you want 4 separate corners tied down. It's redundant, it makes life easier. If anything was to happen to one or other of the hold downs, you always have 2 or 3 more to go. It's how we do it. So you come out 300 and diagonally 300. So you have this. So ratchet straps are what we use. And just a quick wrap, in stunt rigging, we use a lot of ratchet straps because we're using temporary structures and putting things temporarily in place. They're 5-ton on the buckles. They're polyester straps, but they're used for holding down heavy loads on trucks, etc. So they're more than strong enough for our application. 5-ton buckles will hold. We'll do a brake test on just a straight strap pull with the buckle, and you can see what I mean. So we use ratchet straps. What we mount to the floor is Petzl hangers. We use 10 mil Hilti concrete anchors. These are 100 mil by 10 mil. They're self-cut threading. I found these to be the best. I've used redheads that either leave a stud in the ground you have to cut off, or the threaded inserts that you pop in and then expand with a tool, and it leaves a thread, so you can always come back and put threads, put a bolt into the floor. Those work fairly well, but they get filled with dirt and you have to vacuum them out to use them. They have their drawbacks. These, you drill a hole and impact them in. 100 mil long, because most stages allow 100 mil. It's all the new stages, 100 mil depth is the maximum call out on depth. So we drill a hole with the Hilti, with the stone drill. We impact this in. Something to note, when you put this in, do not put it in within an inch of its life. There are tits on the bottom of this thing that will lock it in place. So if you put it in and it is not perfectly aligned with your 45 degrees or whatever angle, your 42, 40, whatever it is, when it's here, if it's not pointed in the direction of pull to this strap, it's gonna wanna twist this anchor. But if it's in so tight into the ground and the tits are sunk in, it'll be cocked and you'll try to pull it and it'll be here until it gradually, at some point, will loosen and orient. Well, that much will cause this strap to loosen. So my suggestion is always put it in lightly tight, tension this up to full tension, and if you really have to, go back and hammer them down. There's no real need. They can be 1 mil loose and do this. It's not gonna hurt this. You're pulling this in shear. You're not relying on the threads to pull it vertically out. You're at a 45 degree angle. You would literally have to snap a 10 mil piece of steel in half to shear this. This anchor will go far before that. This anchor is only good for around 20 kilonewtons. I'd have to look on them. They're stamped. This one says 17 kilonewtons. Okay, so you have to look at your anchors, but that's what we use. We also use Maillon Rapide PK, Maillon Rapide deltas, because we're connecting 50 mil wide straps to a single point load. This is the correct way to do it. Not a carabiner that's an oval or a D, because it wads this strap up. It makes it very, very ugly, and it doesn't help its performance. Here you keep it nice and flat. So that's how we do that portion. We come up, we try to keep the buckles as tight to the floor as possible. Now, every one of your ratchet strap manufacturers is going to tell you you need several wraps on this. So what we do is we come up under the truss with the strap. We wrap the strap from under, take a full wrap, and then come out over and go through the buckle. We then give it a few turns of extra. So right now there's 3 full turns, and then we tighten it up. Some manufacturers want as much as 5 turns. It doesn't have to be gorilla tight. It only has to be cinched up. It's not nuclear tight. It just has to hold it tight to the stickers, to the floor. Now, what you've got is your buckle at the floor, your free strap up here to keep this area clean for operation. And because it's happened before, I've seen poor rope management get rope caught under these. Say the tail of a gold tail you've left laying long and it whips around and it gets caught under here, it can cause problems. It's happened more than once. So we have designed and use covers for these so that we can keep them from catching rope. And this is how we do it. Used to use cardboard, used to use a lot of things. But this becomes a nice, smooth, easy way. The rope will glide over these. It won't hook under the handle. It's flexible. If it catches here, it'll pop off. So this becomes a very nice, clean way to do your base station. All right, moving up to the front. Our base station is anchored down the same, 45 in each corner. The same Maillon Rapide, the same anchor. And remember, folks, when you're using these anchors and Maillon Rapides, Maillon Rapide has a call out on how tight this nut should be. You should tighten it with a wrench, okay? If you can't find the correct wrench, everybody always carries an adjustable. Nip it up with an adjustable, folks. That way you're gonna get the full value of the specs on this link, okay? So what we have in front, you need some way to turn vertical motion into horizontal motion. So that because you're operating on a horizontal plane. So you can either use a flip-flop block, Other people have plates that go on top with multiple pulleys. The problem I have with all of these, other than flip-flops, is the pulleys, when they're not under tension, are flopping around. A lot of guys have pencil anchors bolted to a plate and they clip a sheave to it. What that does is, here's the plate, here's the sheave. When it's not under tension, it's doing this, because you've got a carabiner or a shackle to an anchor, and this is just loose. So when the system goes under tension, it goes wham. When it's not under tension, it just falls. So that's not very effective. That's pretty crude. What we've done is we've designed a angle mounting plate with a pulley inherent that's all 300 mil wide, and it's double bearing. This is a 60 mil roller, kind of like they use for winches or for large equipment. And we can break everything over this on our station. In this case, I have two systems. So the bite system, the service loop system, is running through a flip-flop. The additional thing here is, because of center lines, because of verticals, this is designed to work with 50 mil pulleys. This is designed to be a certain height off the truss cord. So this matches the clutch and the gold tail better than it matches this. So in deference to having this be used, I've just come in as a separate system here to keep the two separated. I can and have rigged both systems to one, because even if this roller is tight doing a ratchet, this rope will slide over a hard anodized roller, and it works like friction rings on sailboats, which this runs through. And if any of you know sailboat stuff, you'll understand. They're basically pulley-less turnarounds. So I could run it through here, run it back, lose this, and go to the clutch. The difference is that the point here is a little lower than I like to have for the clutch, or for the clutch point here. So that bit of fleet in a short distance creates a little more friction in this device. It's not optimal. For a strict drop, it doesn't bother me much. With this rope, it doesn't bother me much. But we try to stay 1 to 2 millimeter in vertical fleet throughout our devices. So in this case, this is probably a better option. So I've used that. Again, whatever your turnaround is, needs to be fleeted to the center line of whatever you're doing here. So in this case, I have a pulley on the head of the ratchet, which is matching the pulleys here. And it also matches, so everything's running in parallel and at the same midpoint. There's no vector pulling. This is not pulling up or down, and it can't flop around. This is strictly will orient where it needs to go. So the exit of this pulley will go to this fixed point under tension, and this will orient to the pulley here and will go out at the fleet here because it's exiting the bottom. So notice the pulleys are arranged kind of diagonally. That's because under tension, these are able to orient. Okay, we're not putting any angular tension on the swivel. Everything's in center line. That's how you need to run your system, because it saves you from cross-loading. If this was pulling at an angle, if this came in vertically and came under here, this would technically be pulling in a vector at this angle, which is putting a huge amount of stress on this swivel, and it would snap there. Well, that point of failure is avoided because everything's pulling in a horizontal plane. This is never pulling out of alignment. These are the things you need to worry about on base stations. So in order to do that, you need to orient your equipment so that it's all on the correct heights. Now, we mount things like flip-flop blocks on plates. This is a 10 mil plate. This is a clutch plate. This is an 8 mil clutch plate. This is a combination plate. And that's again 8 mil. This big plate is one caliber, which will hold just about anything I want all the way across the truss, and it's 12 mil. Okay? So these are all different heights because none of your manufacturers, Spinlock, Harken, have the same callouts for center line from their mounting plate. So sometimes, in this case, this is on a 10 mil plate, this is on an 8 mil plate, yet the center lines are within 1 mil. If they were on the same plate, they'd be more than 2 mil out. Okay, add 2 mils of thickness, they would be more than 2 mil out. Not optimal. So you mix and match the thickness of your mounts to create your center lines. Okay, that's the critical point here. Orienting center lines in the lateral and center lines in the vertical. Center lines in the horizontal, in the lateral, are far more important because it will pull this rod one way or the other if it's not centered. You'll notice that the ram is not tied down in front. That's because it's allowed to float and orient to the direction of pull. It's in a bite of rope, every bite of rope. So if this was pulling a little more this way, it would orient to the center of that, okay? And the same with this, but because this is a 50, that's a 50, and the spacing is set within a millimeter or less on the spacing, it runs dead center under tension. And you know that when you pull up on it, you can see it. This would be our line going to our ratchet. So you can see how it orients, nice and straight, and everything levels out. This point goes directly into that. This point goes directly to the sheave. This is our exit, which is going around our roller. So there's our vertical center lines. The ram is not being pulled down or being pulled up. There will be no flopping, okay? These are the important parts. All right, and the same with this system. When you pull it tight, you'll see that the exit is here, parallels the truss to the entrance here, okay? Now, like I said, if I use this system, ran it through this side, then I would be running a little low for this. Now, to make that a little nicer on this and less friction, I would move this farther back. That way I'm working in the belly of the rope. Now, you have to realize, in a perfect world, if this was solid bar, rod bar, 12 mil in diameter, everything would have to be perfectly straight because bar doesn't bend. Because rope flexes and you can have the belly in a rope, you can get away with a few mils. These all have entrance and exit flares on all of these sailing devices so that you can have a mil or two out. It's not a big deal, but once you start going more than that, you're really fleeting against the edges of your equipment and you're going to tear up equipment. Severe wear, added friction to the system, and it's a rope wear, but with this rope, that's kind of insignificant. This is Technora jacketed 12 mil Dyneema 99 core. This is a 9-ton rope in strength. The jacket is made for severe friction. It's meant to be used in clutches and it's meant to be used on grinder winches on super mega yachts. So this rope will see very little wear. But if you're using other rope, it'll glaze the rope. It'll start creating problems with your rope. So the point here is base stations need to be lined up, they need to be oriented correctly, they need to be pinned down correctly. All right? So that pretty much covers base stations, okay? And we'll get to ratchets at another point, and we're gonna do a break on a ratchet strap, just so everyone who's not from this industry and doesn't mount things with ratchet straps can understand how strong they actually are. All right? Thanks a lot, bye.